GW, and a target of the NAT gateway ID with which will be the ID of the NAT gateway. Note that it is best practice to create one NAT gateway within the public subnet of each availability zone, and then point the route table to the availability zone in the availability zone to the NAT gateway created in the same availability zone. In this diagram, you can see the paired VPC has one internet gateway per VPC and one NAT gateway per availability zone. The private subnet route seed are the same to the NAT gateway. The public subnet seed are the same directly to the internet gateway. To connect your VPC to the internet, you would use an internet gateway, which is horizontally scaled. To connect, and the horizontally scale is to handle the fluctuation of traffic, high traffic, low traffic. To connect to the AWS services privately without the use of an internet gateway or NAT, use VPC endpoints. To connect to the customer's gateway in the customer's on-prem data center, use VPN gateway, which is added to the edge of the VPC. A designated edge network. So here's a few definitions and some examples of CEDAR exactlers. So a designated edge network location in AWS refers to the specific locations in the AWS global network, like AWS edge locations or regional edge caches, where data processing occurs closer to the user. A designated edge network location refers to a specific geographic point within a network infrastructure strategically positioned to provide the closest possible connection to users, minimizing latency by delivering content or services from a location near where the user is accessing them. Essentially, it's a designated point at the edge of the network where data is served to users, often situated in a data center close to major population centers. Purpose: reduce latency and enhance performance by delivering content and service closer to end users, leveraging AWS infrastructure. Key AWS features, for example, AWS Edge Location, part of Amazon CloudFront, used to cache and serve content quickly. Regional edge cache, larger data centers that store content closer to edge locations, improving retrieval speed. AWS local zones extend AWS infrastructure to geographic areas for ultra low latency applications. Applications, content delivery, using Amazon CloudFront to deliver static and dynamic content efficiently. Edge computing, running compute functions closer to end users using AWS Lambda Edge. IoT and real-time services ensure faster processing for IoT applications and real-time data. Some benefits: lower latency, speeds up access to content and services. Scalability, automatically scales based on demand, improving performance during traffic spikes. Improve user experience, faster response times for end users globally. Example in AWS, Amazon CloudFront delivers content from edge location worldwide. AWS Wavelength extends AWS to 5G networks for ultra low latency applications. VPC peering, used to route traffic between the resources in two VPCs. Transit Gateway. AWS Transit Gateway connects your virtual private cloud and on-premises network through a central hub. It helps to create a simplified network and puts an end to complex peering relationships. Transit Gateway is a highly scalable cloud router solution. Each new connection is made only once. AWS reliability and compliance. Some key features, but before we get into key features, there's a clear separation of responsibility. The customer is responsible for security in the cloud, and AWS is responsible for security of the cloud. Customer data, as you see top right, and software AWS is responsible for. Some key features: high availability and fault tolerance. AWS provides globally distributed infrastructure with multiple availability zones to ensure high availability and resilience against failures. Automated backup and disaster recovery. AWS services like Amazon S3, RDS, and EC2 offers automated backup solution and disaster recovery capabilities to ensure data integrity and continuity. Compliance with industry standards. AWS complies with a broad range of international standards, including GDPR, HIPAA, which is required to allow sharing of medical data, etc., to help business meet regulatory requirements. Security and access control. AWS includes robust security frameworks such as AWS Identity Access Management, IAM, encryption, and monitoring tools to ensure data protection and compliance. There's AWS Organization, often used by large corporations. Some key features: centralized management. AWS organizations enable centralized account management and governance across multiple AWS accounts. Account grouping. Organize accounts into organizational units, OUs, for better structure and policy management. Service control policies, SCPs. Apply policies to manage permissions and restrict actions across account and OUs. Consolidated billing. Simplifies billing by combining multiple AWS accounts, offering cost savings with volume discounts. AWS Control Tower. Some key features are automated landing zone. AWS Control Tower helps quickly set up and govern secure multi-account AWS environment and using best practices. Centralized governance. Provides pre-configured blueprint and guardrails for compliance, security, and operational guidance. Account provisioning. Automates the creation of new AWS account with predefined configurations and security policies. Ongoing monitor, another key feature. Continuously monitors accounts for compliance with set policies and guardrails, ensuring consistent governance. The tools CLI and CDK are necessary for implementing the use case that will be discussed in part 2. These will also be necessary to work in any capacity that requires interacting with cloud platform. So if you plan to seek a job in cloud utilizing cloud resources, you will absolutely need to know these. Hence, before you proceed to applying for a job in that field, or you know getting in that field, or certification, or and for the use case, ensure these are working. Follow the provider's instructions for your specific OS. Here are a few information bullet points for you to explore and expand on, especially going into certification. Understanding AWS Service Catalog, License Manager, migrating existing resources to AWS will be questions that you will need to be able to answer on your certification exam, or even for an interview. I'll leave these, won't get deep into these. You can read and then expand on them. There's a lot of readings out there on these. The use case presented here will be implemented in phase 2 video. Note the prerequisites and what will be covered. You must have already set up AWS account and environment. You must be able to interact with the cloud resources via the CLI. Access key ID and secret access key ID should be 2 items you'll receive when you set up your account. In phase 2 of this, the next video, 2 things will be covered mainly. The manual steps, and you will use the AWS console to go through the steps provided to implement the use case. And then I will walk you through programmatically doing this with infrastructure as a code using Terraform and Ansible. Scenario here, imagine you have a small e-commerce platform that has a growing number of users. You want to deploy this web application in the cloud to take advantage of scalability, high availability, and cost efficiency by using a cloud platform such as AWS, GCP, Azure, etc. You can dynamically adjust resources based on the demand, maintain based on demand, maintain redundancy, and ensure the application can grow as your customer does. Assume your client, the assumption that will be made is that the client requests cloud provider to be AWS. The reason why I mentioned other cloud providers such as Google Cloud Provider, Azure, Microsoft, etc., it's because Terraform is platform agnostic. You can use Terraform and Ansible to set up infrastructure and provision on any of these platforms. The commands, etc., will be definitely different, but that's one of the benefits of Terraform and Ansible. Of course, the console, the manual step, is specific to AWS. Here's the architecture diagram that will be implemented. This, as you can see, it's a subset of the diagrams that were presented earlier. So this is extending on what you have learned so far. For those going off to a certification, here are just a few questions, just teasers and some links to additional materials. But these are kind of the questions and answers you will be expected to give within a cloud certification exam or an interview, maybe. Thank you for taking your time to watch this video. We ask that you remember to click the like to support this effort, join our channel, and invite others to join. Many more videos will be posted on a diverse set of tech topics. Artificial intelligence, large language models, generative AI will be extending on ontology engineering, knowledge graph engineering, etc. View our intro video, and we kind of went through what the channel is about. Digital engineering. We'll dive into some examples and give real world examples. Again, thank you and have a good day.